Okay guys, we're going to start with 8.1, which is solving right triangle trig, and this is a trigonometry that you should have learned in geometry, and it's what we're going to be starting our unit with. As we go through our unit 8, there's a couple of different kinds of trigonometry. There's this right triangle trigonometry, and then of course there's going to be unit circle trig, which we'll get into later in the unit. But this is going to be 8.1, solving right triangle using a trig to solve right triangles. So what I want you to do, just somewhere on the paper, it could be over here, it could be over here. I'm actually going to use a scratch piece of paper. I am going to draw a right triangle. So it's going to look like this. Hopefully you can see it. I will move it up here. Okay, so there's my right triangle. And here is my right angle. Notice that on the note packets here, it has this little symbol here, and that is called theta. So let's write that down. So it's a Greek letter theta. And what theta stands for is an angle measure. And right now we're going to be looking at the angle measure in degrees. Okay, so that's what theta is. So when I'm looking at my right triangle here, notice you've got your right angle, and then you've got a couple of acute angles. So I'm going to just pick one. I'm going to pick this one down here, and I'm going to say that this is the angle measure theta, okay? So everything that you do is going to depend on which angle you're dealing with. So if I'm dealing with this angle here, and you possibly remember this from geometry, but if you go straight across the triangle, you're going to run into what we call the opposite side. So this is the opposite side. And if you go next to, then you run into the adjacent side. That's what the word adjacent means. Adjacent means next to. So here's theta. You've got the opposite side, you've got the adjacent side. Now the longest side of the triangle, which is opposite the right angle, has the same name all the time, and that is called the hypotenuse. So that's my hypotenuse. So here's theta, here's my opposite side, here's the adjacent side, and here's my hypotenuse. So if I wanted to find maybe theta, or maybe I wanted to find one of the sides of the right triangle, I'm going to use what we call right triangle trig, and that's going to be sine, cosine, and tangent. So there's a little, well, first of all, let me just tell you what each one of these is. So the sine of theta is opposite over hypotenuse. So I'm going to just abbreviate OPP over HYP. So that's going to be the opposite over the hypotenuse. The cosine of theta is always the adjacent over hypotenuse. So once again, I'll abbreviate. And the tangent of the angle is always the opposite over the adjacent. Apologize, I'm down a little low. And there's a fun little acronym that I use when I am doing trigonometry, and that is called SOHCAHTOA. SOHCAHTOA is a nice acronym to help you remember. Sine is opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent, and that's what these letters mean. Sine opposite hypotenuse, cosine is adjacent over hypotenuse, the tangent is opposite adjacent. So I say SOHCAHTOA is the ratioa, and of course you can imagine the dance I would have for you if we were in school. Now, if we take a look down here, these are probably new to you. You've probably never seen them before. But really, all they are the reciprocals of your sine, cosine, and tangent. This CSC stands for cosecant. And the cosecant is the reciprocal of sine. So the cosecant of theta is going to be the hypotenuse divided by the opposite side. SEC stands for secant. And secant is the reciprocal of cosine. So the secant of theta would be hypotenuse over adjacent. And this COT stands for cotangent. And I think you can guess that that's going to be the reciprocal of tangent. That's going to be adjacent over opposite. So these are the acronyms. So I always say, if you can remember SOHCAHTOA, just remember cosecant, reciprocal of sine. Secant, reciprocal of cosine. How I remember it is this starts with a C, but the reciprocal is your sine. This starts with an S, your reciprocal is your cosine. And then cotangent has a T in it, and that's going to be the reciprocal of tangent. So that's how I remember that, is I just have these memorized, and then I just know that these are the reciprocals of those. So let's do an example, and I believe this might even be on the homework 8.1, but let's do an example using this here. It says, refer to the diagram, give the value of each trig ratio. So all that means is we're going to come up with the ratios, meaning the fractions that go along. Well, remember, in order for us to do that, we have to know all three sides of the triangle. So think back to geometry. How would you find the third side of the triangle? Well, if you recall, that's called the Pythagorean theorem. So first thing I'm going to do is go ahead and find this side QP. I'll go ahead and just call it C for now. So we would say 7 squared plus 24 squared is equal to C squared. And once again, C is going to represent my hypotenuse here. 7 squared is 49. 24 squared, I'm having a hard time remembering that off the top of my head, so I'm going to go ahead and use my calculator here. Sorry about that, guys. Okay, so we're going to do 24 squared, and I get 576. And that's going to equal C squared. So 576 plus 49 is going to give me 625. So if I wanted to figure out what C is, obviously I have to take the square root. So C is going to be the square root of 625, which I happen to know is 25. And you could calculate that if you need. Now, once I have the three sides of the right triangle, right, now what I'm going to do is fill it in. So the sine, remember, the sine is the opposite over hypotenuse. So now which angle is theta, right? Well, what you're going to do is look here and say P. P is going to be the angle that we're looking for. So I'm going to come down here, and this is going to be my angle that I'm working with. So the opposite is 7. The hypotenuse is 25, and I will just simply write 7 over 25. The next question is the sine of Q. Now we're looking at this angle up here. Once again, opposite of Q is 24. Hypotenuse is 25. Cosine of P. Now remember, cosine is adjacent over hypotenuse. So now if I'm here at P, remember adjacent means next to 24 over 25. Hey, take a look at the fact that the cosine of Q is the same as the sine of Q is the same as the cosine of P. And the last one on this side is the tangent of P. Well, remember, tangent is opposite over adjacent. So the tangent of P, here's P, would be opposite over adjacent, 7 over 24. Okay, now let's come over here, and we want to know the cotangent of Q. Well, remember, the cotangent is the reciprocal of the tangent of Q. Well, we did not find the tangent of Q here, so let's come up here. Cotangent is adjacent over opposite. So I'm going to come down here to Q, and we're going to say, okay, so the adjacent to Q is 7. The opposite side to Q is 24. So it's going to be 7 over 24. the secant of p. So the question would be, did we find the cosine of p? We did right here, right? Remember the secant, excuse me, I was painting. The secant is the reciprocal of cosine. So instead of me looking at the triangle and trying to figure it out, I can actually just use this ratio and flip it over, the reciprocal, 25 over 24. The cosecant of p, remember, is going to be the same thing as the sine of p, or the reciprocal of the sine of p, which I did right up here. The sine of p is 7 over 25, so the cosecant of p is going to be the reciprocal of that, 25 over 7. And the tangent of q, right, well, tangent is back to this side here. Remember, tangent is opposite over adjacent, so the tangent of q is going to be 24 over the adjacent 7. And we could have also come up here and said, hey, that's reciprocal. Those are reciprocals of each other. Okay, so that's the first page of the notes on 8.1. Let's move to the second. So why do we need to know these ratios? What we're going to be doing is solving right triangles. And to solve a right triangle, meaning that we're going to be figuring out all the different parts, which there are 6 of them, the 3 sides and the 3 angles, you must know a minimum of 2 side lengths. So this would be an example here. We may want to try and find the angle measure, or we may know 1 side length and an angle measure. And once again, we don't have enough information, so we are going to have to use trigonometry. So let's do an example here where we solve the right triangle. What that means is we're going to solve all 3 parts, actually all 6 parts of the triangle in order to find this. Now, before I begin this example, please make sure that you have some kind of scientific calculator. I just use my phone here, and if I turn it on its side, notice that you're going to see sine, cosine, and tangent there. You are going to need this for this example, so if you don't have it, go ahead and hit pause and go back and get that. All right, so here we go. To solve using trigonometry here, you don't always have to use trigonometry. Sometimes you can solve for different parts based on what you already know, past knowledge, that kind of thing. So let's make a list over here of the 6 parts that we need to find. The first thing we need to find is the measure of angle A. We're gonna also have to find the measure of angle B, and that doesn't necessarily have to be the first or second thing we find. We're also gonna know angle C, and some of this we'll be able to fill in right away. Now we also have the 3 sides. Now notice this is side AC, this is side CB, this is side AB. Well, one of the nice things that we do to help us shorten some of the things that we write is naming the sides based on the opposite angle. So for instance, this is angle A. If I go across the triangle, I would call that small a. And over here, this is capital B, angle B. So if I go across here, I'm going to have side B. So I need to know side A, side B, and side C as well. And like I said, you're going to be able to fill in some of this information. For instance, we know angle C is 90 degrees. We can fill that in. We know that side A is 56. We can fill that in. And we know that side little b is 33. We can fill that in. So I was able to fill in 3 pieces. I have to fill in the other 3. So I'm going to start with what I think would be the easiest thing to do, and that is to solve for side C. We do not need to find or use right triangle trig to do that. We can use the Pythagorean theorem for that because we know the 2 sides. So that's going to be the first thing that I do, is let's solve for side C. All right, so I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared. A is 56. B is 33. Okay, so once again, I'm going to use my calculator for that, clear that out. So I'm going to say 56 squared Oh, where's my squared button? There it is. Plus 33 squared equals, and then that's 4225. Now I want to take the square root of that, which is right on my calculator. It's going to be right here, and I get 65. Okay, so now I can come down here and put that in. So I used the Pythagorean theorem to figure out that. Now the second thing I want to do, I'm going to go back up here and I want to solve for angle C. I'm sorry, A. I want to solve for angle A. Now I'm going to have to use trigonometry to solve for angle A. So once again, if I'm looking at A, how do I know if I'm going to use sine, cosine, or tangent? Well, the way you determine that is based on what you know. I know that 56 is the opposite side of A. Remember, I'm looking for A. And I know that 33 is the adjacent. Opposite, adjacent. Opposite, adjacent. So if I go back to my trig ratio here, opposite, adjacent, notice that that would be TOA, or tangent. So that's how I determine that I'm going to use tangent, because I know the opposite and adjacent side. Now, do I know the hypotenuse as well? Actually, I do. So if I wanted to, I could use either of these as well, using that 65 that I just calculated. But I'm just going to go ahead and go with tangent, since that's what was originally given. That's the only reason why. So I'm going to say that the tangent of angle A is equal to, remember, the opposite, 56, over the adjacent, which is 33. Now, here's the thing. When you are looking for an angle measure, and you're going to use the calculator to do that, the button you're actually going to hit, let me clear this out, when you're looking for an angle measure, and we'll write this down, is you're going to use what we call the sine inverse. Notice I have, or tan inverse. Notice I have sine, cosine, and tangent. So where you see the second button is what we're going to have to hit in order to find the sine, cosine, and tangent. Go back to the original screen, sine, cosine. Before we begin this, you need to make sure you're in what we call degree mode. Do you see where it says RAD there for me? That's what I want, because if I hit this, then that puts my calculator in radian mode. I don't want it. I want it actually to say RAD down here. Now, how you can double check if you're not sure if you're in degree mode is if you hit the sine of 30. Now on my calculator, I have to hit the angle measure first and then hit sine. You should get 0.5. If you do not get 0.5 when you do the sine, then you're not in degree mode, and you're going to need to make sure you are. Okay, so I'm going to go back and clear. So how we would punch this into the calculator is we would have to hit the tan inverse of 56 over 33. Okay, so that's what we're going to punch in. So I'm going to hit second. Now remember, my calculator, I have to punch the number in first. So I'm going to do parenthesis 56 divided by 33. I'm going to go ahead and get that number. Now I'm going to take the tan inverse of that, and I get about 59.4. That's how many degrees angle A is. We'll make it about 59. I'm just going to round it to the nearest whole number, 59. Now, what I want to tell you, and let's write this down as well. Maybe we could do a starred note up here. If looking for an angle measure, you're going to use the inverse button. As an example, tan inverse or sine inverse. If you're looking for the length of a side, which we'll do here in a second, then you just use the regular tan button. Now, I I just noticed that my camera stopped recording when I got to the part of finding angle B. I apologize for that. So let me go back. So we just found angle A was 59. So once we have one of the angles, and we already know angle C, we could think about the three angles of a triangle always add to 180, or you could think about the fact that the two acute angles always add to be 90, or you could say are complementary. So how do we figure out angle B? You could just take 90 minus angle A, and I had written 180 and I meant to write 90. 90 minus angle A, 90 minus 59, angle B is 31 degrees, and that would be your answer for angle B. So the only time we had to use right triangle trig was on the second step of solving for angle A. So step 1 we solved for side C by using the Pythagorean theorem. 2, we solved for angle A by using trigonometry, specifically the tan inverse. And then 3, just knowing that the three angles are going to add up to 180, or the two acute angles add to 90, was enough information to get us angle B. Okay, so that is the second page. Okay, so now we're going to move on, and I believe this is one of our examples from the homework as well, but you're not going to always have to find all 6 sides of a right triangle. Sometimes you may be only asked to find one thing, and once again you're just going to use, in fact we'll write it right here, SOHCAHTOA, to help us determine which trig ratio we're going to use. So the goal here is to find angle F. So here's angle F right here, which means that this would be side little f if I were looking for that. But anyway, back to angle F. So I want to find F. So how do I know what I'm going to use, sine, cosine, or tangent? You say, well, what do I know? I know the opposite of F, and I know the hypotenuse. Opposite hypotenuse is going to be sine. So we're going to say the sine of angle F equals opposite over hypotenuse. Now remember, we're looking for an angle measure, and that was one of our starred notes that we made. If you're looking for an angle measure, you're going to use the inverse button. So we're going to come back, and remember, you got to turn it on its side. I already have second hit, so I'm going to use my parentheses, and I'm going to put 9 divided by 30, and I'm going to go ahead and close the parentheses, and I'm going to get that answer, and now I'm going to hit the sine inverse of that. So there it is right there, and I get about 17, we'll round to the nearest tenth, I believe, 17.5 degrees. And there you go, and there's angle F. So we hit the sine inverse of 9 over 30, and we got approximately 17.45 or 17.5 degrees, and there's your answer. Okay. All right, let's do this one here. Now notice this one we're looking for a side length, so now we're not going to use inverse, but we're still going to set up the same way. So we want to solve just for side B. So how do I know which one I'm going to use? Once again, you always go to your angle, either the angle you're looking for or the angle you're given, and say, what do I know in relation to that angle? I know the hypotenuse, right, is 17, and I'm looking for the adjacent. So adjacent hypotenuse is going to be cosine. Now I know the angle measure is 35. Remember, that's where your angle goes. Cosine of 35 equals the adjacent over the hypotenuse. Now think back to algebra. How would we solve that? Well, if you wanted to solve and your variable's in the numerator, you just simply multiply these two together. So we're going to take the cosine of 35 and we're going to times that by 17. Now, how would we punch that into the calculator? Okay, so let me go to clear, And I'm going to go back to my regular, because we're not looking for an angle measure here. Now on my calculator, I have to figure out the cosine of 35, and to do that I have to hit the 35 first, and then I'm going to hit the cosine. Now I'm going to times that by 17, and I get 13.9, and there's your answer. And that would be in terms of centimeters. Okay, so there's another example. So our last example on SOHCAHTOA stuff is a word problem, and the best way to do a word problem is to draw the diagram. A 20-foot ladder is leaning against a wall. The base of the ladder is 3 feet from the wall. What angle does the ladder make with the ground? So let's draw a diagram. So here's the wall, and we have a ladder that's leaning up against the wall, okay? Now, what do we know about the ladder? The ladder is 20 feet. So I know that this right here is going to be 20 feet. And obviously not drawn to scale. It should be not leaning that far because the base is 3 feet from the wall. Okay. What angle does the ladder make with the ground? So I'm going to call that theta. That's what we're looking for right there. Obviously the wall should be standing straight up and down at perpendicular, so I'm going to put my right angle there, and I'm looking for this. So now I'm going to go to my SOHCAHTOA and say, and let me write that up here. I always like to write SOHCAHTOA on my paper right in front so I know what I'm going to be using. So I want to find theta. What do I know? I know the adjacent and the hypotenuse. Adjacent hypotenuse will be cosine. So I'm going to say the cosine of theta equals the adjacent over the hypotenuse. Now I'm looking for an angle measure. What button will I hit on the calculator? Remember the cosine inverse. So let me hit clear. So I'm going to have to hit second, go down where I have those buttons there, and I'm going to hit 3 divided by 20, close parenthesis, and now I'm going to hit the cosine inverse of that. So cosine inverse is going to be right there, and I get about 81.37 degrees, so about 81 degrees. There you go. Perfect. Let me write down here also what we punched into the calculator. We hit the cosine inverse of 3 over 20. That's how we calculated that. Okay. The last topic that we're going to cover in 8.1 was something that you learned in geometry, and those were called special right triangles. Special right triangles, there's actually 2 kinds. So the first kind is an isosceles right triangle. So if you recall from geometry, isosceles triangles have base angles that are congruent as well. Well, if it's a right triangle, remember earlier we said the 2 acute angles add to 90. That means that each of these angles must be 45 degrees. So we will do that on both of these. So this would be the first special right triangle because it is what we call a 45, 45, 90. Now, let's fill in the missing sides. If it's isosceles, that means that both of these sides are 3. Now, how would I figure out the hypotenuse? I don't have to use trig for that. I could use the Pythagorean theorem. 3 squared plus 3 squared is equal to c squared, my hypotenuse. So 9 plus 9. 18. So if I want to find c and I take the square root of 18, now we're not going to punch that into the calculator, we're actually going to simplify that. Simplify meaning 9 times 2, or some of you could make the tree, however you want to do it. The square root of 9 is 3, the square root of 2 left over, and that would be your hypotenuse. Okay, so that would be a special right triangle. Now, if I do the same thing over here, I know that's 5, and I go ahead and use the Pythagorean theorem to solve for the hypotenuse. I would get 25 plus 25, which is 50. And if I take the square root of 50 and break that down where 1 is a perfect square, I get 25 times 2, which is going to be 5, the square root of 2, and there's your hypotenuse there. And so if we were in class, I would say, do you see a pattern? 3, 3, 3 square root of 2. 5, 5, 5 square root of 2. So if I gave you a third one, mark these congruent, and I said 7, hopefully you would say, oh, then this is 7 and this is 7, the square root of 2. The reason why we call it a special right triangle is because the length of the sides have a special relationship. You can know just one thing about the triangle and be able to give me the rest of it. And that's what's beautiful about a 45, 45, 90. You just have to know one side to know everything else. So the second type of one is called a 30, 60, 90. So if this is 60 and this is 90, we know this is 30. So let me see if you can figure out the pattern on this one. So now the hypotenuse C is 10. The smallest side usually is what we call A. So our unknown side is going to be B in this case. So using the Pythagorean theorem, 5 squared plus B squared equals 10 squared. 25 plus B squared equals 100. If I subtract 25 from both sides, I get B squared equals 75. Take the square root, and I get 25 times 3, which is 5, the square root of 3. And so if I come up here, I know that this side is going to be 5, the square root of 3. Now let's take a look at this one, kind of the same thing. This time we've got the 60-degree angle here, 30, 60, 90. That's another right triangle. And once again, we're looking for the medium side, B. So using the Pythagorean theorem, A squared plus B squared equals C squared. 3 squared plus B squared equals 6 squared. 9 plus B squared equals 36. Subtract 9 from both sides, and I get B squared equals 27. And if I take the square root of 27 and simplify that, 9 times 3, I get 3, the square root of 3, and here is B. So let's see if we can see a pattern here. 5, the square root of 3, 10. 3, the square root of 3, 6. So once again, if I did a third triangle, let's say this is 30 and this is 60. If I said 7, then this side is going to be 7, the square root of 3, and the hypotenuse will be 14. So here's the pattern. You double the smallest side, that's your hypotenuse, and your medium side is whatever the small side is times the square root of 3. So that's how special right triangles work. So there's two of them. There's the 30, 60, 90 and the 45, 45, 90. So what I'm going to do is I'm going to give you a chart to use that you can use to solve for these triangles. So I'm going to let Q equal the side you're given. So if I come back up here, notice that I did know two sides, but what if I didn't know the 10? Now that I know the pattern, I could easily know the 10, right? I would say, oh, well, that's the smallest side, that's double, right? And 30, 60, 90 is the side opposite the given. So if Q is opposite the 30, or is Q opposite the 60, or is Q opposite the 90, here's the pattern. So if you know the side opposite the 30, and I'll just draw a little diagram down here just for that one. So we'll say there's 30 and there's 60. So if I know Q is here, and Q is just whatever number it happens to be, then remember I know that the side opposite the 60, or the medium side, is that the square root of 3. And the hypotenuse is always double whatever the smallest side is, so that would be 2Q. Now, in a perfect world, we're not always going to know the side opposite the 30 or the smallest side. So let me give you some case scenarios here, and I'll just give you the formulas. What if I know the side opposite the 60? Work backwards. I would divide by the square root of 3, right? But then I would have to rationalize my denominator. So this one becomes q the square root of 3 over 3. And this one is double that, 2q the square root of 3 over 3. And the last case scenario is you know the side opposite the 90. Well, remember that is always double the smallest side. So if I want to work backwards, I would cut that in half. Q over 2, and this would be q over 2 the square root of 3. So I'll show you how we're going to use that pattern to get us through the next few problems. Now for the 45, 45, 90, there's only two case scenarios. You're either going to know a leg or you're going to know a hypotenuse. So if you know one leg, then you know the other leg is the same. And the hypotenuse, remember, was that the square root of 2. That was the one we just did. But the other case scenario is we know the hypotenuse. If you know the hypotenuse, then to work backwards, you would divide by the square root of 2, rationalize your denominator, and you would get q the square root of 2 over 2, and the other one will be the exact same thing. So what I'm going to do, just for example purposes, I'm going to name each row, or number each row. So I've got row 1, row 2, row 3, row 4, row 5. And one of the things I want you to do is when we look at a problem, I want you to say, which row am I going to use? And I'll show you how that works. So I'm going to leave that out for us. So here's our first example. Hopefully we can see that. So the first thing I'm going to do is say, what kind of triangle is it? Is it a 30, 60, 90, or a 45, 45, 90? Well, I see a 30 there. So I know it's a 30, 60, 90. So I know I'm going to be using row 1, 2, or 3. Okay, it's going to be one of these. Now, which one is it? What do we know? Do we know opposite the 30, opposite the 60, or do we know the hypotenuse? And notice that we know the hypotenuse. Remember, Q is your given side. So when I look at which row I'm using, I want Q to represent what I know. I know opposite the 90, so Q would go here because that's what that is. So when I go back, I would say, okay, well, which row has a Q under the 90? Row 3. And that's the row I want to use. So I know it's going to be Q over 2 and Q over 2 the square root of 3. Now, to fill in the rest, I would say, okay, I want to know the side opposite the 30. Well, remember, Q is 8. Actually, why don't we do this? Instead of going over here, let's fill it in. So Q is 18. That's what we know. So this is going to be 18 divided by 2 times the square root of 3. Well, hey, that's 9, the square root of 3. And this one's just going to be 18 over 2, which is just 9. Right? So now I know all 3 sides of the right triangle. So opposite the 30 is simply 9. And so if that's 30, this is 60. Opposite the 60 is 9 the square root of 3. And you're done. Easy peasy. Okay? Let's do one more. I think this is my last example and we're done. Once again, I'll keep that chart handy here. So now I see a 45. So now I know that it's going to be either row 4 or 5. So once again, I'm going to say, what do I know? Once again, I know the hypotenuse. So if I go 45, 45, remember Q represents what you know. I know the hypotenuse. So I'm going to use row 5. Which is Q the square root of 2 over 2, Q the square root of 2 over 2, Q, put in my Q, which is 24, and then I just fill in the rest. So 24 the square root of 2 over 2, well, that's 12 the square root of 2. And the other one will be the exact same thing. So I have the 45. My camera keeps shutting off. I apologize for that. I hope, but luckily we're almost done. I believe I was about here where it shut off. All I did was simplify. And remember, x is going to be opposite the 45s. So therefore x is going to be 12 the square root of 2. And there you are. All right, guys, so that is 8.1. So now, once you've got the notes, I want you to go back through Google Classroom, and there is a worksheet that goes along with this lesson that I would like you to complete. And once you have completed it, go ahead and take a picture and email it to me. I will be posting my email address on Google Classroom in case you don't have it. All right, so this is the first lesson of the week. We'll be doing at least one, possibly two more this week as well. All right, take care, guys. Talk to you later.